and Assalamualaikum everyone. We are Group 4 from class TS1432B. We're presenting our discussion about chosen question in Assessment 3. Our group consists of 4 members. First one, Nurul Fatin Fatihah binti Abdul Ghani. Second one, Nur Akilah binti Yahya. Third, Nur Amira binti Syamsul Johari. And lastly, Nur Naziha binti Khairil Muslaimi. Our question is about topic application of differentiation. Before that, did you know that application of differentiation have 5 subtopics? First, related weights. Second, analysis of function 1. Third, analysis of function 2. Fourth, applied maximum and minimum problem. And fifth, Rolle's theorem and mean value theorem. In details, our question is about applied maximum and minimum problem.
What is differentiation? Differentiation is finding the slope. The derivative represents how fast something is changing at an instant. For example, derivative can tell you how fast you are making a profit based on the amount of money that you have, how fast something is filling up based on its value, or how fast anything changes given a function representing the value of that anything.
For your information, other than application of maximum and minimum problem, it is also known as an optimization problem, where are usually applied maximum and minimum has been used. First, it is usually used in industry world. Second, is used for the business person if they want to know the minimized cost and the maximized profit. Third is used for the traveler. If the traveler wants to minimize transportation time, they need to use the optimization problem. Fourth is used in the manufacture. They use the optimization problem to find the least amount of material to make a particular object. Here are some steps that we need to apply to solve this question. First step is we need to understand the problem. We need to know what is the unknown, what is the given quantities, what is the keywords that we can use to solve this problem. Second, we need to draw a diagram of this question. It helps us to visualize what is the question needed. Third is introduce notation. Assign a symbol to a quantity that is to be maximized or minimized. Fourth is express question in terms of some of the other symbols from step 3. And the last one is after we use step 1 until step 4, we need to solve the question given. Here is the problem statement that our group chose, which is from questions 5. A rectangular storage container with an open top is to have a volume of 10 meter cube. The length of its base is twice the width. Material for the base costs 10 ringgit per square meter. Material for the sides costs 6 ringgit per square meter. And the question is, we need to find the cost of materials for the cheapest such container. Alright, now we need to start with the solution. Let's go! And here is the solution. First step, we need to carry out what is the information given to us. The information given to us is volume is equal to 10 meter cube, and the information about the length is equal to 2 times the width. So we denote that x as a width and y as a height. And the information say that length is 2 times the width, so we denote length as a 2x. And we know that volume is equal to length times width and times height. We multiply all these variables is equal to 2x times x times y is equal to 2x squared y. We substitute 10 into the v because v is the volume. We already know that 10 is equal to volume. So 10 is equal to 2x squared y. We need to find y because after that we need to find area in terms of x. So we find y, we get 5 is over x squared. Next, we need to find the area. Why we need to find the area other than we find the volume? Because we know the information about the volume. This is because in the questions, it already gives us the information about how much the area per square, right? Remember? And because of that, we need to find the area. The area for each side. Okay, the first one, 2x squared is equal to base, where 2x times x plus 2 bracket xy is equal to left and right side, which is they have 2 sides here and we need to multiply by xy, plus 2 times 2xy. This is for the front and back sides, alright? 2 times 2xy. Then we need to solve this equation and we get 2x squared plus 6xy.
Next, we need to find the derivative for the cos. It is given that the base cos is Rm10 per square meter and sine is Rm6 per square meter, which gave us the function 2x in the power of 2 multiplied with 10 plus 6xy multiplied with 6. Simplify the function and substitute y with 5 over x, which gave us 20x in the power of 2 plus 180 over x. Bring up the x and we got 20x in the power of 2 plus 180x in the power of negative 1. So, we have a cos function in the term of single variable and simplify. Our next step is to calculate the derivative for this equation. We compose the power of 2 to multiply with the coefficient of 20, which gave us 40x, and use the power of negative 1 to multiply with the coefficient of 119, which gives us negative 180x.
To get the value of x, the first derivative need to equal to 0. Therefore, 40x minus 180 over x squared equal to 0. Then move the negative 180 over x squared to the right, and it will be 40x equal to 180 over x squared. To make the x at only one side, we move x squared to the left, and it will be 40x cubed equal to 180. Then do the mathematical solving as usual by bringing 40 to the right, and it will divide the 180. Turns out it will be x cubed equal to 4.5. We also need to move the cube to the right as only x on the left side. Therefore, x will equal to cube root of 4.5. As the answer, we will get x equal to 1.65. Bonus, we can also find the value of y even though in this problem it didn't require us to find the value of y. Since we have made y in terms of x at the earlier calculation, we just use that to find the value of y. Y is equal to 5 over x squared, then we substitute x equal to 1.65 into the equation, and we will get y equal to 1.84. Then, we can calculate the total cost. To know the total cost of the container, we need to substitute the value of x in the total cost formula, which is 20x squared plus 180 over x. Therefore, it will be 20 times 1.65 squared plus 180 over 1.65. Using calculator, we will get 54.45 plus 109.09. And the final total cost is 163 ringgit and 54 cents.
Lastly, to know whether it is maximum or minimum, we use second derivative. Here we got c prime equal to 40x minus 180x to the power of negative 2. So we need to double prime the c. It equal to 40 plus 360x to the power of negative 3. And then we need to replace the x with the value of x, and we will get 120.14. The value is more than 0, so the graph of f is concave upward. So it is minimum.
So, we can conclude that this topic can be used to find maximums and minimums of function given by formula. For example, for your question, you can find the cheapest cost of material for rectangular storage container, which is Rm163.54 C by using differentiation technique.